The Great Debate, Flat versus Round, written by Neil deGrasse Tyson in Astrophysics. For centuries, humans have debated the shape of our planet. Is it a flat disk or a giant sphere? This debate may seem strange today as we have undeniable evidence of Earth's roundness. Yet the flat Earth theory persists, a testament to the enduring power of belief over evidence. This essay explores both sides of this ancient argument, examining historical beliefs and scientific evidence that ultimately reveals the truth about our planet's shape. A world on a plate, early beliefs. For much of human history, the prevailing belief was that Earth was flat. This made intuitive sense. After all, when we look around, the ground appears flat. Ancient civilizations often envisioned the Earth as a flat disk surrounded by a vast ocean or dome-like sky. This concept appears in various mythologies and religious texts. For these cultures, the Earth represented the center of existence, a stable platform around which the heavens revolved. Shadows in the sky, Aristotle's eclipse. The first cracks in the flat Earth theory began to appear in ancient Greece. Around 350 BC, the philosopher Aristotle observed something peculiar during a lunar eclipse. He noticed that the Earth's shadow, as it crept across the moon, was always curved. This observation was crucial. A flat object would cast a shadow with a straight edge, not a curved one. Aristotle's simple yet profound observation provided early evidence that the Earth was in fact a sphere. Measuring the Earth, Eratosthenes' insight. About a century after Aristotle, another Greek scholar took this observation further. Eratosthenes, a mathematician and geographer, devised a method to calculate the Earth's circumference. He knew that the sun cast different shadow lengths at different latitudes. Using this information and basic geometry, he calculated the Earth's circumference with remarkable accuracy. This was a groundbreaking achievement, providing further proof of Earth's spherical shape and demonstrating the power of scientific inquiry. Beyond the horizon, sailing into the unknown, as humans ventured further out to see more evidence for a round Earth emerged, sailors observed a curious phenomenon. Ships sailing over the horizon didn't simply disappear all at once. Instead, they vanished gradually, hull first, then masts, as if sinking below the curve of the Earth. This observation, easily explained by a curved surface, contradicted the flat Earth model. It provided tangible, visual evidence that the Earth's surface curved downwards, hiding objects beyond a certain distance. From the ground-up perspective and altitude. Another observation that supports a spherical Earth relates to perspective and altitude. Imagine standing on a flat plane. As you look towards the horizon, your line of sight remains parallel to the ground. Now imagine climbing a mountain. As you ascend, your horizon expands, allowing you to see further. This is because your line of sight is now at an angle to the ground, revealing more of the Earth's curved surface. Celestial shifts, constellations and hemispheres. Looking beyond our planet, the stars themselves offer compelling evidence for Earth's shape. As you travel north or south, the constellations you see in the night sky change. For example, the North Star, Polaris, appears higher in the sky the further north you travel. This phenomenon occurs because your position on a curved Earth changes your angle of view relative to the stars. On a flat Earth, everyone would see the same constellations regardless of location. Perhaps the most definitive piece of evidence against a flat Earth came in the 16th century. In 1522, Ferdinand Magellan's expedition completed the first circumnavigation of the globe. By sailing westward and eventually returning to their starting point, they proved conclusively that the Earth is round. This feat of exploration not only expanded our geographical knowledge but also provided undeniable proof of our planet's true shape. In the age of aviation, pilots provide further contemporary evidence of Earth's curvature. When flying at high altitudes, particularly on long-distance flights, pilots must constantly adjust their trajectory downwards to follow the Earth's curvature. If they flew in a straight line without making these adjustments, they would eventually veer off into space. This constant need to compensate for Earth's curvature is a testament to its spherical shape. The most irrefutable evidence of Earth's shape, however, comes from the space age. Since the mid-20th century, satellites and spacecraft have captured countless images of our planet from space. These images show, without a shadow of a doubt, that Earth is a sphere. Astronauts who have had the privilege of seeing Earth from orbit have all described it as a breathtaking blue sphere hanging in the blackness of space. While we often refer to Earth as a sphere, it's not perfectly round. Due to the centrifugal force created by its rotation, Earth bulges slightly at the equator and is flatter at the poles. This shape is known as an oblate spheroid. However, this slight deviation from a perfect sphere doesn't invalidate the overwhelming evidence for Earth's roundness. Despite overwhelming evidence, some people still cling to the flat Earth theory. This persistence is often attributed to a distrust of authority, a reliance on selective information, and the allure of conspiracy theories. Some individuals find comfort in believing they possess secret knowledge that most of the world overlooks. It's essential to approach these beliefs with empathy while firmly advocating for scientific literacy and critical thinking. The debate over Earth's shape highlights the importance of questioning, observing, and testing our assumptions about the world. Science provides us with the tools to understand the universe around us, but it requires open-mindedness and a willingness to accept evidence, even when it challenges our preconceived notions. By embracing scientific principles and engaging in critical thinking, we can continue to unravel the mysteries of the cosmos and deepen our understanding of our place within it.